In 2022, cold starts killed serverless adoption. Developers went back to Kubernetes because they couldn't afford a 400 millisecond penalty on every function invocation. In 2026, that problem is gone. Here's what changed. Welcome to AmTalk Soft. I'm going to give you the most practical breakdown of the serverless versus Kubernetes debate that exists in 2026, because it's genuinely a different conversation than it was 2 years ago. Here's what we'll cover. First, why this debate is suddenly relevant again. Second, what Serverless 2 actually means and why the name matters. Third, what's changed inside Kubernetes that makes it more competitive for smaller teams. Fourth, the WebAssembly wildcard that's changing the edge computing game entirely. And finally, a clean decision framework so you know which to pick for your next project. Whether you're a developer choosing a platform or an architect reviewing your stack, by the end of this video, you'll know exactly what to use and when. Let me set the stage. In 2019 and 2020, serverless was the hottest thing in cloud computing. AWS Lambda, Google Cloud Functions, Azure Functions, everyone was pushing functions as the future. No servers to manage, pay per millisecond, scale to zero automatically. It sounded perfect. Then reality hit. Cold starts. You'd fire up a Lambda function and wait 300 to 400 milliseconds while the runtime spun up. That's not acceptable for latency-sensitive applications. If you needed persistent connections, like WebSockets or database connection pools, serverless made it awkward. If your functions ran more than 15 minutes, you were out of luck. So teams went back to Kubernetes. Kubernetes isn't simple, the learning curve is steep, and the operational overhead is real, but at least it was predictable. Between 2021 and 2023, Kubernetes became the default for anything serious. Fast forward to 2026, two things happened simultaneously. First, the serverless vendors solved most of the hard problems. Cold starts dropped from 400 milliseconds to under 10 milliseconds, and at the edge, effectively zero. Second, the Kubernetes ecosystem matured enough that platform engineering abstractions made it significantly less painful to operate. Both platforms got better at the same time. That's why the conversation is worth having again. Serverless 2 isn't a product announcement. It's a set of capabilities that arrived across multiple platforms roughly between 2024 and 2025 that fundamentally changed what serverless can do. The 4 defining characteristics. 1. Near-zero cold starts. The V8 isolate model, pioneered by Cloudflare workers and now adopted by Versal Edge Functions, Deno Deploy, and AWS Lambda's Snap Start, means functions start in microseconds, not milliseconds. A V8 isolate is like a lightweight JavaScript execution context, much cheaper to spin up than a full container or even a micro VM. Snap Start for Java functions on Lambda pre-initializes the JVM state and snapshots it, cutting Java cold starts from 8 seconds down to under 300 milliseconds. 2. WebAssembly as a runtime target. This is the big one. You can now compile Rust, C, Go, Python, or TypeScript to WebAssembly and run it in a serverless environment with near-native performance. Fastly's compute platform and Cloudflare workers both support WASM natively. This breaks the assumption that serverless means JavaScript. 3. Stateful serverless. Cloudflare Durable Objects and Oz DynamoDB Streams integration mean you can maintain state across function invocations without an external database. This solves the WebSocket and real-time use case that killed serverless adoption in 2020. 4. Longer runtimes and larger packages. Oz Lambda now supports 15-minute function timeouts, 10 gigabytes of memory, and container images up to 10 gigabytes. The package size limit that forced you to strip out dependencies is essentially gone for most use cases. Serverless 2 is not your 2019 Lambda. It's significantly more capable and significantly more competitive with containers. Meanwhile, Kubernetes didn't stand still. 3 changes made it dramatically more accessible for teams that aren't Google. First, platform engineering abstractions. The rise of internal developer platforms, tools like Backstage, Port, and Cortex, put a self-service UI on top of Kubernetes complexity. Developers no longer need to understand pod anti-affinity rules or pod disruption budgets to deploy a service. They fill out a form. The platform handles the YAML. This massively reduced the expertise needed to run Kubernetes safely. Second, event-driven autoscaling via KEDA. The Kubernetes event-driven autoscaling project lets you scale workloads based on external signals: Kafka queue depth, RabbitMQ message count, database row counts, even HTTP request rates. Before KEDA, the horizontal pod autoscaler could only scale on CPU and memory. KEDA made Kubernetes responsive to the same signals that serverless platforms respond to automatically. You can even scale to 0 with KEDA, which was previously only a serverless capability. Third, managed Kubernetes got genuinely good. EKS, GKE Autopilot, and AKS have absorbed most of the control plane pain. GKE Autopilot in particular provisions nodes on demand and manages resource allocation automatically. You deploy workloads and the cluster handles scheduling. It's not quite as hands-off as serverless, but it's dramatically simpler than running your own cluster. The result, Kubernetes in 2026 is a realistic choice for teams of 5 to 10 engineers. In 2022, you needed at least one dedicated platform engineer to run it safely. That's no longer true if you're on a managed service with modern tooling. WebAssembly deserves its own section because it's genuinely changing the rules of the game, and it doesn't fit cleanly into either the serverless or Kubernetes category. Here's the core idea. WebAssembly is a binary format that any browser or WASM runtime can execute with near-native performance. It's sandboxed, portable, and fast. Originally designed for the browser, it's now running in production on edge networks worldwide. Cloudflare runs over 300,000 WASM-based worker functions at more than 200 edge locations globally. When a user in Singapore makes a request, the function executes at the nearest edge location, often 5 to 10 milliseconds from the user physically, rather than routing back to a data center in Virginia. There is no cold start because the WASM module is precompiled and cached at the edge. Fastly's compute platform, Deno Deploy, and Versal Edge Runtime all use similar models. And critically, you're not limited to JavaScript. You can write your edge function in Rust, compile it to WebAssembly, and get Rust-level performance at every edge location on the planet. Where does this fit relative to serverless and Kubernetes? Think of it as a third tier for latency-critical, stateless computation. Not everything needs to be at the edge, your database certainly isn't. But for authentication checks, A/B testing logic, response personalization, and API gateway logic, Edge WASM is often the best choice in 2026, regardless of what you're using for your core backend. Let's put them side by side across the 6 dimensions that actually matter for infrastructure decisions. Cold starts, serverless 2 wins, V8 isolates are sub-millisecond, WASM edge is effectively 0. Snapstart Lambda is under 300 milliseconds for Java. Kubernetes has no cold start concept. Your pods are always running, which costs money but means 0 startup penalty. Cost: it depends entirely on traffic shape. Serverless excels at spiky or unpredictable workloads. You pay only for actual invocations. Kubernetes has a fixed floor cost. You're paying for nodes whether they're idle or at 90% utilization. If you have consistent high traffic, Kubernetes is usually cheaper per request. If you have bursty traffic or a side project that gets 0 traffic at 3 in the morning, serverless wins on cost. Operational complexity: serverless wins at small team scale. No nodes to manage, no upgrade windows, no pod disruption budgets to configure. Scaling behavior: serverless scales to 0 and to thousands of concurrent invocations automatically. Kubernetes with KEDA gets close sub-minute scaling for most event-driven workloads. Stateful workloads, Kubernetes wins clearly. Persistent volumes, stateful sets, and direct database connection management are native. If you're running a PostgreSQL database, a Redis cluster, or a Kafka broker, that's Kubernetes full stop. Vendor lock-in, both have it. Lambda's event source integrations are deeply OS-specific. Kubernetes with standard YAML is more portable, but managed Kubernetes services each have their own resource model. WebAssembly and the WASI standard are the most portable option. A WASM module runs on any WASM runtime without modification. Here's the decision framework I actually use. Use Serverless 2.0 when your traffic is unpredictable or bursty. You're a solo developer or small team that doesn't want to manage infrastructure. Your functions are stateless and complete in under 15 minutes. You're building APIs, webhooks, event processors, or scheduled jobs. You want to get something to production in hours, not days. Use Kubernetes when you have stateful workloads, databases, caches, persistent queues. You need fine-grained resource control, specific GPU access, persistent volume configurations. You have existing container workloads that are already Kubernetes native. You have a platform engineering team that can absorb the operational cost. Or you're building for compliance environments that require specific node configurations. Use WASM at the edge when latency to the end user is your primary constraint and your operations are stateless. You're running logic close to users, auth checks, A/B testing, geo-routing, request transformation. Your function completes in milliseconds and doesn't need direct database access. The honest answer for most new projects in 2026, start serverless. Graduate to Kubernetes when you have a specific reason, stateful workloads, GPU requirements, or a consistent traffic baseline that makes fixed node costs cheaper than per invocation pricing. Five mistakes I see regularly. 1. Running serverless with long-running database connections. Lambda is not designed for persistent connection pools. Use RDS proxy or PG bouncer in front of your database, or switch to DynamoDB for serverless native data storage. 2. Over-engineering with Kubernetes for a side project. If you're the only engineer and your app serves a few thousand users, a managed serverless platform costs you nothing at low traffic and requires no operational attention. Kubernetes for a side project is almost always the wrong call. 3. Ignoring cold starts for latency-critical paths. Even with Serverless 2's improvements, a snap-start Java function at 300 milliseconds is too slow for a user-facing login flow. Profile your actual cold start performance before committing to serverless for latency-sensitive endpoints. 4. Treating WASM Edge as a replacement for your entire backend. Edge WASM is for stateless, fast logic near the user. Your auth database, your order processing, your machine learning inference, that's not Edge territory. 5. Choosing based on hype rather than workload. The best infrastructure is the one that fits your actual traffic pattern, team size, and operational budget. One more way to think about it. 3 questions determine the right answer. First, do you have stateful workloads, databases, caches, persistent queues? If yes, Kubernetes. Second, is latency to the end user your primary constraint and are your operations stateless? If yes, WASM at the edge. Third, is your traffic unpredictable and your team small? If yes, serverless 2. These aren't mutually exclusive. Many production systems in 2026 use all 3. Kubernetes for the stateful core, serverless functions for event processing and integrations, and WASM edge functions for request routing and personalization. The hybrid architecture is increasingly the norm. Quick recap. 1. Cold starts are mostly solved in Serverless 2. 2. Kubernetes is significantly more accessible in 2026 thanks to managed services and platform engineering tooling. 3. WebAssembly at the edge is the new category you need to understand. 4. Stateful workloads still belong in Kubernetes. 5. Most new projects should start serverless and graduate to Kubernetes only when there's a specific reason. The right choice isn't serverless or Kubernetes. It's knowing when to use both. If this helped you, subscribe. We publish deep dives on cloud architecture, AI engineering, and platform engineering every week. The next video covers WebAssembly beyond the browser in detail. If you want to understand how WASM works at the systems level, that's the one to watch. And if you want to support the channel, buymecoffee.com/AmticSoft. See you in the next one.